Okay, guys, today I'm going to talk to you just a few general things before we start with exponents tomorrow. So, a few general things about our sets of numbers. So, if I can quickly run through the symbols that we have for our different number sets. That is important that you must know these things and that you know what numbers belong in each of them. So when we start with our first set of numbers, that is our natural numbers. Okay, and in the natural numbers, we have basically the numbers 1, 2, 3, and so on. So it's all of them, it's whole numbers, and there's no decimals or fractions or anything, and it starts at 0. Then we have our whole numbers, and the whole numbers actually the same as the natural numbers, but it starts at 0, 1, 2, 3, and so on. This is the end with a 0. It says it's the natural numbers, but it starts at 0. Then we have our integers that's normally indicated by the letter Z. Now the integers are the numbers that now include the negative numbers, -2, -1, 0, 1, 2, and so on. So these are called our integers. Okay, now you can see that the integers include the whole numbers and it also includes the natural numbers. Then the next set of numbers that we have is our rational numbers. Now guys, the rational numbers, we can't really write it like 1, 2, 3, 4, whatever, because the rational numbers include now fractions and decimal numbers. What we have is the definition for a rational number is any number that can be converted as a fraction. So any number that we can write as a fraction is a rational number. Examples of rational numbers will be, if I take for example a 2 is a rational number because 2 can be written as 2 over 1. So that is the normal numbers that we have. Then we have our decimal numbers. That is also because if you have like 3,2, it can be written as 32 over 10. Remember, there's one digit after the comma, so it's a tenth. That is a decimal number. Even if it is more like 2,753, it can be written as 2753 over 1,000. There's 3 digits, so this is called a rational number because it can be converted into a fraction. If we have a mixed number like 2.5, it can be written as denominator 2, and then we say 2 times 2 plus 1 is 5, so it can be converted into a number like a fraction with an a over b. Some of our surds, not all of them, but some of our surds, for example, if I have the square root of 16, the square root of 16 is 4. 4 can be written as 4 over 1. So some of our surds are called rational numbers. And then even our recurring decimal numbers, like if you have 2,3 that recurs, this is also a rational number. Now, I think in grade 9, they showed you how to do it, but I'm just going to quickly 2.3. I'm just going to put a lot of 3's and I'm going to go way back. And if I say equals here, it converts it to 7 over 3. So this is also a rational number. Okay, so those numbers are called our rational numbers. The definition for a rational number, very, very, very important. It is any number that can be converted into a fraction. That is the definition that we have for a rational number. Then if we have our irrational numbers, so So the symbol that we use is Q with an accent there. It's our irrational numbers. So the irrational numbers are all the numbers that is decimals that is not ending. Okay, so something like 2,31784,319 da 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 da. This is an example of a irrational number. Or our surds where we need our calculator. For example, the square root of 13. I can't work it out. I need my calculator where the square root of 13 is the square root of 13, or it is 3,605551275, and if the calculator was bigger, it will just continue. So those numbers are our irrational numbers. And then very, very, very important, the number pi is also a recurring number. Not a recurring number, is a rational number, because if I put pi on the calculator, you will see, and even if you check on the computer, 3,141592659 da 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 da. There's millions of decimals. So pi is not a rational number. Now I know that we said pi is 22/7. Now you can think, but I wrote it as a fraction, so why is pi not a decimal number, not a rational number? And guys, the reason here is this pi that we have is actually not equals to, it's almost 22/7. So very, very important, pi is not a rational number, pi is a irrational number, because it's not exactly 22/7, but it's the closest fraction. So it's the closest fraction, closest to 22/7. That is not exactly. Okay, that is why pi is a irrational number. But then we also have our real numbers. So the real numbers are all the numbers that exist. Okay, all the numbers. That means it's decimals, it's fractions, it's surds, it's any number that exists, except for the square root of a negative number. Because if I take the square root of 5, for example, -5, the square root of -5, okay, you'll see that my calculator is converting it to a I, but your calculators will show math error, okay? So if it gives you a math error on the calculator, it means that it does not exist, and that then we call, so except these numbers and these numbers that I have there, I'm going to call them non-real numbers. Okay, so the real numbers are all the numbers that exist, and the only ones that do not exist is the ones that will show you a math error.